You should use the law of sines when you're finding a missing measurement in a triangle and you know the measure of an angle and its opposite side. Let me give you an example of that. You're probably writing that down right now, but I'll give you another second to write while I'm drawing a triangle. Let's suppose, for example, you have a triangle, probably based on some word problem or something like that. And you have three sides, and I'm just going to call them, we'll call them E, F, well, we have three angles, E, F, and G. We'll use the capital letters for the corners. We'll use lowercase letters for all the sides that are across from that. So across from big E is little e, across from big G is little g, and across from big F is going to be little f. Now, we will use the law of sines when we're finding a measurement in a triangle and you know the measure of any angle and its opposite side. So let's suppose that the problem was set up like this. Let's suppose they told us the measure of angle F. Let's suppose they said it was 42 degrees. And they also told us that little f was, I'll make this up, we'll just say it's 12 centimeters. In a situation like this, we would use the law of sines. Now we need to know a little bit more. So let's suppose they also gave us the measure of angle E. Let's say that it was 35 degrees. And let's suppose they said find little e. In a situation like this, we would just set it up. Now, since this problem is not in your packet, we're not going to go through this one to completion, but we would set it up like this. Sine of big E is going to be 35 divided by little e, and that's what we're looking for, and sine of big F divided by little f. There we go. Now, obviously, you can see on the bottom where it says we use the law of cosines if you do not know the measure of at least one angle and its opposite side. Basically, when you don't use the law of sines, you use the law of cosines. There, of course, is a third one, and it is right triangle trigonometry. That one, I hope, would jump out at you when you see a right angle in a triangle. So that's when you use it. Let's go ahead and do the next problem. A triangular pasture is made by fencing in the area around three posts. Posts A and B are 62 feet apart. B and C are 57. A and C are 43. What is the angle of the fence at post C? Okay, let's draw this picture. So we have triangle ABC. It does not have to be accurate. So A, B, C. It doesn't have to be drawn to scale is what I mean. A and B are 62 feet apart. B and C are 57 feet apart. And A and C are 43 feet apart. Okay, and then it says, what is the angle of the fence at post C? So they're looking for this one. We'll put a theta there because usually we use Greek letters in the corners when we're dealing with angles, particularly beta, alpha, theta, ones like that. And we are looking for the measure of angle C. So let's ask ourselves a question. First of all, do we know any angle and its opposite side? And no, because we're looking for C and we don't know big B and we don't know big A. So we will not be able to use the law of sines. We're going to have to use the law of cosines. Okay, this one is going to get a little bit crazy because we're looking for the angle measurement. So since we're going to use the law of cosines, we need to find the appropriate formula. We're looking for big C. So we're going to use the formula that starts with the letter C. Now, of course, it starts with the little letter c, but that's okay. So here's the formula. C squared equals A squared plus B squared. We'll pause here and state something that this should look very familiar to you. That works for right triangles, of course, Pythagorean theorem. But it is this that helps it work when it is not a right triangle. So that's the piece of it that helps it work when it's not a right triangle. And we're going to plug the numbers in. Now, again, little letters are across from big letters. So little c is across from big C, so this is 62. Little a is 57. And little b is 43. Minus 2 times a times b times the cosine of c. Now, in a minute we're going to have to do some stuff on the calculator, so before we go any further, before you ever do trigonometry on the calculator, make sure your calculator is set to the appropriate angle measurement. Most of the time your calculator will need to be in degrees. We want this answer in degrees. Let's always assume it's in degrees unless it states otherwise or unless the problem says so. So we're going to set calculator to degrees. That is so important. I'm going to write it down. Calculator to degrees. You will miss the problem if you do not set your calculator to degrees. And so we need to press mode, and then you'll be able to see where to go from there. You go down and change it to degrees. So make sure you're in degrees. We're going to work on this problem a piece at a time. And let me point out a very common mistake from the beginning, and let's avoid it. Some people like to type all this in the calculator. That is illegal. This is one term, this is another term, and that is all one term. So we are not going to be able to put this piece with the other parts. However, these two just being regular numbers that are squared, those are like terms. We can also find out what that is. And we can find out what that is, and when we're done finding it out, we'll put a cosine C with it. So let's type some stuff in the calculator, figure out what to do with it. 62 squared is 3844. 3844 equals, we'll go ahead and put those two together. 57 squared plus 43 squared is 5,098. And then that piece with the cosine C attached at the end of it on our paper is going to be negative 2 times 57 times 43. 4902. Cosine big C. Okay, where do we go from here? Well, we're looking for C. And let me state something that I'd like to think is obvious. It looks like you should be able to subtract those, but you cannot. This is one term. This guy has a cosine C and this guy does not. They do not go together. They're not like terms. What we're going to do instead is subtract. So we're going to subtract 5,098 here. Subtract 5,098 here. It's going to cancel those, which is kind of the whole point. 3844 minus 5098. Negative 1254. Don't panic that it's negative. It's okay. Equals negative 4902 cosine of C. We're going to keep finding C. In the process of doing this, we will need to divide. I'll use a red pen. We're going to need to divide negative 4902. It's going to cancel those. Negative 4902. It's going to be about 1/4, but we'll find it exactly. Negative 4902. Yep. Now, in order to be accurate, I'm going to carry all these decimals with me. I know I normally tell you to round, but when you're dealing with things like trigonometry, sine, cosine, tangent, it's easy to mess up if you don't carry some of the decimals with you. So if you don't write it down, I suggest you at least carry it with you in the calculator. And by that I mean that you need to type in second and answer. It's the negative button, and that pulls up the previous answer. So that's going to be equal to cosine C. Let's make that look like an equal sign. So that equals cosine C. The final answer is going to be this right here. C is going to equal the inverse cosine. It's going to be this little thing right here. Cosine -1, you'll hit second and cosine. And then 25581395335. Save yourself some trouble. Don't type that. Hit second and the negative button. Pulls up answer. Again, if you're not in degrees, you're going to miss it. And we just found it. C is a 75-degree angle. If you want to use a couple decimals there, that's fine. 75.18 if you're going to round to the nearest hundredth. Normally with degrees, we don't.